Hello. So for this video, we'll be discussing extreme values. So the first theorem that we're going to go over is that a continuous function, f of x, on a closed interval of a and b has both a minimum and a maximum value. So if I did not have an interval, for example, on, let's say, this graph on the left, it currently only has a local maximum and a local minimum. There's no absolute max or min because the graph opens both down and up, meaning that it goes upwards to infinity and downwards to negative infinity. But if we are to take an interval, let's say from here to here, it now has a absolute maximum at this point here and an absolute minimum right here. And same can be given with this one. For example, on this graph over here, on the right side, it currently does have an absolute maximum, as right there, because it opens both downwards, so it's possible for it to have a maximum, but it does not have a minimum, absolute minimum, as it has a local minimum right there. But if we were to take an interval, let's say from here to here, it now both has a minimum and a max, but these are now absolute minimums and maximums on this interval. There would be the absolute maximum and the absolute minimum would be right there. So a critical point on a graph is when the derivative of f of x, so f prime of x, equals 0, or the derivative does not exist. For example, on this absolute value graph, when the slope, when there is a minimum, which would be right here, this is currently a absolute minimum. But if you were to take the derivative of this graph and plug in the point of x equals 0, you would get does not exist for the derivative, because the slope coming in from this way and the one coming in from this way do not ever converge towards one given value for the slope, as one's going negative and one is positive. So you'd get it does not exist. So Rolle's theorem states and says that assume that f of x is continuous on an interval of a and b and differentiable on a and b. If f of a equals f of b, then there exists a value c between a and b such that the derivative of f of c equals 0, which clearly makes sense, because if you have a graph that, let's just say it goes out that way and, I don't know, here, as long as the y value of this point and this point of both, I'll mark it in A, B, are equal, then no matter what this graph does in between the interval, as long as it is continuous, it will have both a minimum and a maximum between A and B. As we can see, would be the absolute maximum would be there and the minimum would be there. So here's the example problem that I'm going to work out for you guys. So the first thing that you do, so the question is find the extreme values of f of x equals 2x cubed minus 9x squared plus 12x on the interval of 0 and 3, between 0 and 3. So the first thing that you do is you derive your equation. So we find f prime of x, which equals, it would be 6x squared minus 18x plus 12. And then the second step would be to set this to 0. So we can factor out 6. And then we can factor this to find our answers. 2. So therefore x equals 1 and or 2. So after we find the two, what these would be called our critical points on this graph, we, oh my god, OneNote. I hate this program. How do you, I'm sorry, I'm just trying to, there we go. Okay, so now we have the x values as 1 and 2 on f of x, meaning that these are the two critical points. So we've now plugged these back into the main equation, which is, oh, I forgot it, it was sorry, this is cubed plus 12 times 1 would equal 2 minus 9 plus 12, which equals, negative 7, 5. Therefore, f of 1 equals 5. You would completely do exactly what I just did, but instead of 1, you would do for 2, and you would get f of 2 equaling 4. So that means that on your graph, when x equals 1, the y value is 5, and when x equals 2, it is 4. But because we are on the interval between of 0 and 3, and these two values that we found of 1 and 2 are not necessarily the, if I can insert a space here, that'd be brilliant, OneNote. We have to also plug in for x as 0 and 3, because currently we're looking at a graph, for example. We have between 0 and 3. So we know that for f of 1 it equals 5, and f of 2 is 4. Now we know that the slope is 0 for both these points, but we're not sure as to whether these are local minimums or maximums, or absolute minimums and maximums on the interval, because the actual y value of 0 and the y value of 3 could be greater than or less than these 2 points. So we plug in 0, so f of 0 would be, well, it comes out to 0, and then we also plug in f of 3, which ends up being 9. So we know that now this point is on this graph, and 9, well, it would be a farther up than what my actually illustration is, but so we know the graph goes something like this. Meaning that although, yes, the slope is 0 when x equals 1 and 2, meaning that these are on the graph, not on the interval, these would be both local minimums and maximums, but however on the interval, we know that we can clearly see that the absolute minimum will be at when x equals 0, y equals 0, and the maximum would be when x equals 3 and y equals 9.